All right. So this question, the diagram below, not drawn to scale, shows the relative positions of three reservoirs, B, F, and G, all on level ground. The distance BF is 32 kilometers, FG is 55 kilometers, and angle BFG is 103 degrees, and F is on a bearing of 42 degrees from B. The first question is to determine the bearing of B from F. So, Zach, I'm gonna explain this one with you because I know you sent it to me, right? So I wanna go through it with you so that you understand what the solution is. Cool?
Cool.
Right. So it says the bearing of B from F, right? Now, if you're looking at the bearing of B from F, it means F is the starting point because wherever is the from, wherever it says from, that's the starting point. And that's where you want to draw your north line, right? So I'm going to draw my north line here at F. Actually, before I even get to that, we have the bearing of B, sorry, we have the bearing of F from B already. That's this bearing here, right? That's what they said here. They said F is on a bearing of 42 degrees from B. So if it's from B, it means your starting point is at B. That's why you have this north line here at B, right? And the bearing is the angle between the north line at B and the line BF, the line connecting B to F. So that's why this angle of 42 degrees tells us the bearing of of F from B. However, they are asking us to determine the bearing of B from F. So now we need to put a north line at F because that's our new starting point, right? And the angle between the clockwise angle actually between that line, that north line at F and the line connecting B to F. So this line, this angle is your bearing because the bearing is always the clockwise angle, right? So again, it's the north line. The north line is going to be at F because we're looking at the bearing of B from F, and your bearing is the angle between the north line here at F and the line connecting B to F. So the line BF, right? So this angle is made up of this part inside here that is 103 degrees, as well as this angle on the outside here. But we don't know what that angle on the outside is. So we need to find that angle. And to find that angle, what we will do is we'll use the principle that this north line at B and this north line at F, they're parallel lines, right? And if they're parallel, it means that this angle, these interior angles here of 42 degrees, and this one, I'm using a different color for this angle over here, they are supplementary, meaning that they add up to 180 degrees. So this angle, right, on the outside is equal to 180 take away 42, which will give me 138 degrees, right? So this angle on the outside here plus 42 gives me 180. So therefore, this angle, which I'm interested in finding, is 138 degrees. 180 take away 42. Now, because all of these, this angle of 138 that I just found, this angle of 103 degrees on the inside, and the one on the outside here are all around a point, they all add up to 360 degrees. So I can find what this angle on the outside here is by saying 360 degrees take away the sum of 103 plus 138. And that would give me, let's see what that would give me. That would give me 119 degrees. So the angle on the outside there is 119 degrees. And the bearing, right? The bearing of B from F, which is this whole angle on the outside. Let me use a different color. This entire angle here is made up of this 190 degrees plus this 103 degrees. So therefore, the bearing of B from F will be 190 degrees plus 103 degrees, which will give me 222 degrees. Anybody was able to get this question correct?
Miss.
Very good, right? So 220 degrees, 22 degrees will be the bearing of B from F. Zach, did you understand? Or
Yeah,
do you want
miss.
me to explain it again?
I understand it now, miss. Thank you.
Okay, cool. Right, so let's move on. So that question is with 1 mark. I can't believe that question is with 1 mark alone. But anyway, let's move on. It says calculate the distance BG, giving your answer to 1 decimal place. So let's go back and look at our triangle here. Actually, let me put the screen on 2 page so I could see it. Right. So it says calculate the distance BG, given your answer to 1 decimal place. Well, where's BG? BG is this unknown side here, and we have two known sides and the included angle. So I'm not sure if you all recall, but when you have two included sides, sorry, two sides and the included angle, we can use the cosine rule.
Yeah, miss, I remember that.
Good. So using the cosine rule, we'll say BG squared is equal to the sum of the squares of the other two sides. So 32 squared plus 55 squared minus 2 times the product of the two other sides. So 2 times 32 times 55 by cos of the included angle, 103 degrees. So let's work it out. All right, so this would be, let's go on our calculators. I mean, you could type this whole thing on your calculator, but let's just do it piece by piece. 32 squared is 1024 plus 55 squared.
2025.
Yep, 3025 minus 2 times 32 times 55, which is 3520 by cos of 103 degrees. Well, I could recall it's cos of 103 degrees as well. Anyway, let's just leave it like that for the while. All right, so this would be equal to, now I'm going to type this entire thing on my calculator. 1024 plus 3025 minus 3520 cos of 103. It's a really big number. So BG squared is equal to the square root of this whole thing here, right? Not BG squared, sorry, BG would be equal to the square root of that whole thing, which is really, you know what, let's do it piece by piece. The number is 4840.827711, right? So then the square root of that is 69.6. Anybody got that?
No, I didn't get it.
Anybody got it?
Yes, miss. I get it.
69. Zach, where did you write
Miss, I
down?
get it.
Excellent.
Miss, I
Perfect.
put 23 degrees. I don't know where I get 23 degrees from,
Oh,
miss.
okay. So that's your mistake.
Miss, I try to figure out where I get 23 degrees from, miss. Like, I think I was real tired when I was doing this.
Probably. Tristan, Maya, Misha, did you all get it?
Yes, miss.
Hey. Maya, did you get it? I can't hear Maya. Maya, are you there? I'm not hearing Maya at all. I wonder if she's here. Okay. Tristan, did you get this answer?
Miss, I honestly didn't get a chance to do it.
Oh, okay. No problem. Did you follow?
Yeah, miss.
Okay. Make sure to make some time to do your little extra practice, okay?
Yeah, I would.
All right. Good. So let's look at the next part of the question, which is calculate to the nearest degree the bearing of G from B. Right. So from B means you're starting at B, right? And you want the bearing of G from B. So the bearing of G from B would be the angle between the north line here at B and the line that connects B to G, so the line BG. So that's this whole angle here. We already know that this little piece is 42, so we need to find out what's the angle FBG, and then we add those two to get the full bearing of G from B, right? So we need to use I guess we could use the sine rule. We could also use cosine, but let's use the sine rule to figure out what this angle FBG is equal to. All right, so I'm just doing this so I could see it on both, so I could see what I'm doing, right? So using the sine rule, I'll zoom back out just now, guys. Using the sine rule, side B, which would be the side opposite angle B. So this would be the side B here, right? So that's 55 degrees. 55 degrees over the sine of angle B, which is what I'm trying to find, is equal to, well, the only other side we have there is, and well, you need the angle as well. So that's why you need to use this side over here, side F, because we have angle F. Now, if we had angle G, I could use the side G, which will be 32 kilometers, but I don't have that angle opposite it. So we need to use the sides that the angle that we do have, which is 103 degrees. So it will be the side, which is 69.6 over the sine of 103. Let's go. So that would be cross multiply. We're going to cross multiply here. We'll say 69.6 sine of angle B is equal to 55 times sine of 103 degrees. So therefore, sine of angle B is equal to 55 sine of angle 103 divided by 69.6. So therefore, sine B is equal to, let's see what that is, 55 sine 103 divided by 69.6 is 0.76997634. I'm going to write the whole thing here, but you don't need to do that. But it's best to only approximate at the end of your workget to get the most accurate answer. So therefore, B, remember, whenever you find any angle, you have to take the inverse function. So you take sine inverse of that, of 0.76997634. So on my calculator, I didn't cancel it as yet. I left this value on it, and I'm just going to press second function sine to get the sine inverse. And I press equal. I get 50.0 They said to the nearest degree, so the nearest whole number. So this will be 50 degrees. Anybody got 50 degrees?
Not 50.4.
Well, they said to the nearest degree, right? So the nearest degree means that you have to round up to the nearest whole number fired. So it will be 50. If it was to one decimal place, it will be 50.4. But because it's to the nearest degree, that means it's to the nearest whole number, so it's 50. Okay? Fired?
Yeah.
Right. So this here is 50 degrees. So therefore, the full bearing of G from B, right? G from B is 50 plus 42. How much is that?
92.
92. So the answer is 092 degrees because remember you have to write bearing as with 3 digits.
Yeah.
Okay, let's look at question B. A person at the top of a lighthouse, TB, so this is the lighthouse here, the straight line, sees two ships, S1 and S2, approaching the coast as illustrated in the diagram below. The angles of depression are 12 degrees and 20 degrees respectively. The ships are 110 meters apart. Complete the diagram below by inserting the angles of depression and the distance between the ships. So first of all, the angle of depression would have to be the angles at the top, right? From T looking down at ship 1 and ship 2. So it says the angle of depressions are 12 degrees and 20 degrees respectively from of ship 1 and ship 2. So first with ship 1, remember your angle of depression is formed between the horizontal and the line of sight. So if you're at this point up here, you're trying to find the angle of depression of this point, let's say this point T to this point S, then it's going to be the angle between the horizontal at T and the line connecting T to S. So it's going to be this angle over here. So we got to find that angle on the diagram, right? So S1 is this line from here. Let me use the annotations from Zoom first. This would be better. So I could draw it. Right. So your horizontal at T is this line. Use a darker color, sorry. Yes, so your horizontal is this line here at T, right? That dotted line that they had. And then your line of sight, the line connecting T to S1 would be this line over here. So therefore, your angle of depression of S from T would be this angle over here, which is how much?
12 degrees.
12 degrees, yeah. So this
About 6-7.
sorry? You what?
Nothing, miss.
Okay, right. So this angle is 12 degrees, right? And then your angle of depression from T to S2 would be the angle between these two lines. They kind of mixed it up, by the way. I'm now realizing that they mixed it up. The bigger one should be 20 degrees and the smaller one should be 12. I hate when CXC does this. But anyway, let me show you again. So the angle of depression between T and S2 would be this angle here, right? And then the angle of depression between S1 from T would be, well, that green line, the horizontal, and this one over here. right? So really and truly, this angle is obviously bigger, right? This one here on the outside, the angle of depression of S1 from T is the bigger angle. So that one should have really been 20 degrees. And then your angle of depression of S2 from T should be the smaller one between here and here, which is 12 degrees. That's really how it should have been. So they wrote it. They didn't write the correct thing. So that would be the proper diagram. All right. So what they should have had here is they should have put S either of S1 and S2. It would be 20 degrees and 12 degrees respectively, not what they wrote here. So it should have been 20 degrees would be the angle of depression of S1 from T, and then of 12 degrees of S2 from T. Right. Well, what else we need to write on it? The ships are 110 meters apart. So that means from here to here is 110 meters. So that's all the information that we have there. First question is to determine TS2 between the top of the distance TS2 between the top of the lighthouse and the ship and ship 2. Okay. All right, so let's see how we do that part. TS2, that's the 12 degrees one. And this here is 110 degrees. Okay, so let's draw that triangle outside. You can't use Pythagoras' theorem as yet because we don't have enough information to do that. Right? So not Pythagoras' theorem, sorry, regular trig ratios. So hold on, just give me 1 second, please. Let's use regular trig ratios like SOHCAHTOA to find the distance TS2 because we don't have enough information to do that. However, we do have other things that we can use from right here to use maybe the sine rule, right? So if, let me ask you guys, if this whole angle here, right, of 20 degrees, that is this one here, right? The angle of depression, sorry, of S1 from T is 20 degrees, and the angle of depression of S2 from T is 12 degrees. Can I find out what is this smaller angle inside here?
Yeah.
What would I do?
My
Sorry, I didn't hear you, love. Can you repeat that?
minus the 20 degrees on the curve degrees.
The 12 degrees from the 20 degrees, correct, right? So let's draw over the diagram, right? Because we want to find out what is the measurement of, what is the distance. So this is S1 here, and this is, I'm going to draw it outside so that we could see it more clearly. And up here is T, right? So yes, we could say this angle up here is what I'm trying to find. That's the angle between the 20 degrees and the 12 degrees. So this angle here is 8 degrees. Yeah? Because 20 take away 12 is 8. All right? And something else that you could figure out, guys, is, let me show you this. Well, that horizontal line, right? This horizontal line here at T and this other horizontal line here at BS2, they are parallel lines, right? This line is parallel to this line. So that means this line over here is a transversal. The line TS2 is a transversal, right? The line TS1 is also a transversal, but I'm interested right now in TS2. So if I draw that line TS2 here, that is a transversal. So that means, right, that these two angles, this one over here of 12 degrees and this angle over here are equal because they are what we call alternate interior angles. So this angle here is also 12 degrees. All right, so on the diagram, that would be over here. This angle over here. This angle is also 12 degrees. Right? So if we look at our diagram now, we have this angle up here, which is 8 degrees, this angle down here, which is 12 degrees, and then this length, S1 to S2, is 110 meters. Can we also find what this angle over here is, guys? This third angle in the triangle? Now that we know that this one up here is 8 degrees, that first angle is 8 degrees, and the second one is 12 degrees, what would be the third angle in the triangle?
160.
How much?
You angle from S1,
Yeah, the angle at
turn over,
S1. What would that angle be
160.
equal to? 160, yes. How is it 160?
Because the other side of S1 is the 30 degrees, and how it have a straight line running, and a straight line is 180. You 180 minus the 30, you do 160.
No, that's not the reason. The reason is that these are three angles in a triangle. So angles in a triangle add up to 180 degrees. So this angle will be, this angle here would be 180 take away 20, which would be 160 degrees. But with what you're saying, were you saying that this angle here is 20 degrees?
Yeah.
Yeah, well, that's correct as well. That is correct as well. Sorry. And it's because they're on a straight line. I'm sorry. You are right as well. This angle here is also 20 degrees because of the same principle that we just looked at. The same reason being that T, this line at T, and this line BS1, well, BS2 are parallel lines. So this line is the transversal, which means that this angle of 20 degrees is the alternate interior angle to this one. Yes, fired. I'm sorry. The
Right.
question I was asking was just why, because of this triangle, how we could find this third angle, right? And the response that I was looking for is just that there are three angles in a triangle. But you are correct that the other reason that this angle is 160 degrees is because this one is 20 and they are supplementary. Okay, so now we have three angles and we need to find this side of TS2. So we can use the sine rule, right? So using the sine rule, when you have three angles on any side, you can use the sine rule to find a second side or a third side. So using the sine rule, I want to find TS2. So it would mean TS2 over the sine of the angle opposite that one, which is 160 degrees, is equal to 110.
Is it 110?
Yeah, correct. Over sine of what, Zach?
20, 80?
8.
80, 80, 80.
Yeah, the angle opposite that. This is 8 degrees, right? So the angle opposite that one. Good. So then we cross multiply. So we'll say TS2 times sine of 18. So, sorry, not sine of 18, sine of 8 is equal to 110 by sine of 160. So then TS2 is equal to 110 sine of 160 divided by sine of 8. So TS2 is equal to,
The second answer.
yeah, what you got, love? Tell me.
I got 2.439639888.
Try it again. 110 sine of 160
Yeah.
divided by sine of 8.
Pretty sure. Wait. Yeah.
What you got
Oh,
now?
I got 2.439639888.
No, Zach, you're doing something wrong, love. Let me see. Did you type exactly 110? Is your calculator in degrees, by the way?
My thing's saying science and radians.
Right, so no, it has to go in degrees, right?
Oh,
So
it's which?
do you see a line that says DRG? Sorry, a button that says DRG on your calculator. So are you using a sharp?
Yeah.
Right. So under mode, there's a button that says DRG. You seeing it?
No.
Send me a picture of your calculator real quick.
No problem.
So,
I got 270.326
correct.
7766.
That's correct. So they tell us to determine to the nearest meter. So that's why I rounded it off to 270 meters, right?
Okay.
Good. So the answer
Thanks.
is 270 meters. Anybody got this? Anybody got this question correct?
Me, miss.
What? Very good, guys. Keep it up. Those of you who didn't get it, I hope you understand. And if you don't understand, please let me know. We'll go through it again. And the next question is to determine the height of the lighthouse. So the lighthouse is TB, all right? So determine the height of that. Well, if we know that this angle here is 20 degrees. Can we use anything here, boy? And then this, oh, actually, we can use regular trig ratios for this part we just found the length of TS2, right? So that means we have this right angle triangle here. Let me show you. We have TB S2, this triangle. We already know that this angle on the outside here is 12 degrees, right? And we also worked out that this side is 270 meters. So we can go ahead and use trig ratios using this angle of 12 degrees and this side of 270 meters to find this side TB. So this side TB, first things first, I hope you all recall that when you're using trig ratios, you need to label your sides. So your angle of reference is this angle of 12 degrees here. 270 meters is your hypotenuse, right? And the side that we want to find, TB, is our opposite side. So the ratio that
I wish
uses,
I was high on pod news.
say then please don't do that again. To find when you have the opposites and the hypotenuse, you need to use the sign, right? So let's go.
So katoa.
That's right. Sine uses the opposite and the hypotenuse, right? So that would be sine of angle 12 degrees is equal to the opposite, which is the side we're trying to find, TB, over the hypotenuse, which is 270 meters. I just zoomed out so that I could reference the other page.
Miss, you could do
Right.
it like that, we can understand it. So, yeah.
I find it kind of real small.
Oh, okay, miss. Anything is up to you. So,
I just want everybody to be able to see. So this will be TB is therefore equal to 270 by sine of 12. So that would be 270 sine of 12, 56 meters. Anybody got that? $56 meters.
Yeah, miss, I got it.
MS.
Beautiful. Right. Let's take a short break, guys. We'll start back. It's 4:48. So let's start back at 5 p.m. Right. So the diagram below shows a quadrilateral PQRS where PQ and SR are parallel. SQ is 8 centimeters. Angle SPQ is 90 degrees. Angle SQR is 82 degrees and angle QSR is 30 degrees. Determine the length PS. Okay, well, there's several things we could do, right? One of the first things that's just like standing out to me here is that they said that PQ, the line PQ and SR are parallel, right? And if they are parallel, it means that this line SQ would be a transversal. Therefore, this angle of 30 degrees is going to be equal to this angle over here, since they will be alternate interior angles. So you kind of look for the Z shape, right? Like this. You look for the Z shape where these two lines are parallel and this line is the transversal in the middle, right? So that means that angle up there is 30 degrees over here. Let me put it in a different color. This angle over here is also 30 degrees since they are parallel, right? And I mean, we could find out what this angle here is too, because if this is 90 and this is 30, that's, what's that? 90 plus 30 is 120. So then this angle here will be 60 degrees. But not only that, that line here, PSR, is a right angle. So therefore, 30 plus 60 would give you 90, right? But since they didn't really tell us that, well, yeah, it is parallel. Sorry, it is parallel. It is perpendicular since PQ and SR are parallel. Good. So the first thing we need to do is to determine the length PS. Now, this is a right angle triangle, so we can use not Pythagoras. I keep saying Pythagoras. We can use SOHCAHTOA. All right. We need to find this side, which will be if we're using, let's say we're using this angle here of 30 degrees, then this side, PS, will be the opposite side, since it's opposite the angle of 30 degrees, and the given side is the hypotenuse, since it is opposite the right angle. We recall which ratio uses opposite and hypotenuse. That's sine. So therefore, sine of 30 degrees is equal to the opposite side, PS, over the hypotenuse, 8. So therefore, PS, the side that we are trying to find, is equal to 8 times sine of 30. Anybody got through with this question? 8 sine of 30.
Yeah, miss.
Yeah.
What's the answer?
That's all. I look back. Hold on.
Pat, what you got for the answer?
4 centimeters.
That's correct. 4 centimeters is correct. All right. And let's now look at the next spot, the length PQ. Let's see the length PQ. Okay. Well, you can use, if PS is 4 centimeters, we can actually use Pythagoras. The whole time I'm only saying Pythagoras for whatever reason. We could use Pythagoras' theorem to find the length PQ, because you can use Pythagoras' theorem once you have two sides in a right angle triangle. Or you could use SOHCAHTOA, right? You could also use SOHCAHTOA to find PQ. Let's use Pythagoras' theorem since we haven't used that in a while, right? Now, by Pythagoras' theorem, by Pythagoras' theorem, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So let's just write using Pythagoras' theorem, since that's what we're using. Right? So using Pythagoras' theorem, 8 squared would be equal, well, let me write it with the sides first. So the side PQ squared plus the other side, 4 squared, would be equal to the square of the hypotenuse, which is 8 squared. So therefore, if PQ squared plus 4 squared is equal to 8 squared, then PQ squared will be 8 squared take away 4 squared. Now, 8 squared is 64, and 4 squared is 16. 64 take away 16 is 48. So PQ squared is equal to 48, which means that PQ is equal to the square root of 48, which is 6.9. Anybody got 6.9 as the answer?
Yeah.
Okay.
Perfect. What did you guys use? Pythagoras' theorem or SOHCAHTOA?
SOHCAHTOA.
Okay, cool. So you see how regardless of if you use SOHCAHTOA or Pythagoras' theorem in this question, you would still get the correct answer. I took the answer to 1 decimal place. All right, and now to find the area of PQRS. PQRS. Okay. Well, in order to find the area of PQRS, we need to find the area of PQS and then add it to the area of PSR. All right, let's see how many marks this question is worth. It's 3 marks. It's just because you have a little extra things to do here. Well, firstly, we could find the area of PQS, this triangle, by using base times height divided by 2. And then we would need to find the area of PQRS. And you can also, now the height of this triangle will be known because, let me show you why. Anyway, let's do it piece by piece. So first, let's find the area of PQS using the regular area of PQS. Yes.
I feel I do the question back to front. So the
Oh,
first answer
shucks.
I put 6.9, right?
Uh-huh.
And for the second question I put 4 centimeter.
Okay, I'll take that into consideration when I'm correcting it.
I must.
All right, so 8 fours are 32. Oh, wait, sorry, why am I using 8? I'm using the wrong thing. Oopsie, I'm supposed to use 6.9 because the base of PQ would be 6.9 and the height will be PS. So it'll be 6.9 plus 4. The height and the base of a triangle are perpendicular to each other. That's why I need to use 4 and 6.9, right? So 6.9 plus 4 divided by 2 would be 6.9 plus 4 divided by 2. I got 5.45. 5.45 cm squared. So that would be the area of PQS. Now we need to find the area of QSR, right? So there are 2 things that we can do. First, we can recognize that we can use the height, right? The same height PS would be this height over here. This would also be the perpendicular height of this triangle, right? And we already know that that is 4 centimeters, right? That's 4 cm because that's the same as this height over here. All right. However, we're missing one piece of information there, which is the base. We have the height, but we need to find the base. So we need to find what is the length of this side over here, right? So to find that length, well, we'll have to use the sine rule because you have 2 angles. Well, you could actually have 3 angles for this triangle since we already know what 2 of the angles are equal to. can we find the third angle if we know what two angles are equal to, guys? In a triangle PQSR, can we find what the angle R is equal to?
Yes.
Yeah, how would
Yes.
we do it?
Yeah, it said I think you have to, because the thing is out of 180, right?
Yes.
So we have 30, so we add that to 82.
Yeah.
And then whatever I know what that is will be that remainder.
Correct. So
Okay,
it'll
I
be
know the
180.
algebra, but
It'll be 180. Take away the sum of those two. So this angle will be 68 degrees.
yep.
Yeah, because angle R, let me write it here, right? So angle R is equal to 180, take away the sum of 82 and 30. And that's equal to 68 degrees. All right, so once we have that, now we can use the sine rule to find this side SR. Okay, so using the sine rule, SR, the side that we're trying to find, will be over the sine of the angle opposite SR, which is 82 degrees, right? 82 degrees there. So sine of 82 is equal to, and then the other known side of the triangle QSR is 8 centimeters, and that's opposite the angle R. So that'll be 8 cm over sine of 68. So now we cross multiply. We say SR times sine of 68 is equal to 8 times sine of 82. So therefore, SR would be equal to 8 sine of 82 divided by sine of 68, which is equal to 8 sine 82 divided by sine of 68 is 8.5 to one decimal place. Right? So now I have the base and I have the height. So I could just go ahead. I could do two things here. I can either use the formula to find the area of a non-right angle triangle, which is half of the two known sides multiplied, half of the product of the two known sides multiplied by sine of the included angle. So I can either do half multiplied by 8 times what we just got, 8 times 8.5 by sine of 30, or I can just do base by height divided by 2. So the area of QSR, I'm going to just use base by height divided by 2, right? Would be equal to 8.5 times 4 divided by 2. So that will be 17 square centimeters. So the total area now of PQRS, not PQSR, not that it matters, but anyway, PQRS would be, well, 17 plus 5.45, which will give me 22.45 square centimeters. Anybody got that answer? 22.45 squared cm. Aaron, tired. Zach, y'all got it?
Miss, I still confused. Now we got
Miss, I get it.
5.45.
5.45? Where is that? Where was that? Oh, that was here. from the
Yeah.
area of PQ. Did you understand how I got the second part though? The area.
Yeah.
Okay, well, let's go back to PQS. So the area of PQS, right? So this is the triangle PQS here. Let me draw it. PQS, right? Right, Zach?
Yeah.
The first thing we did is we found this side PQ, all right? And we, where did I get 4 from again? Did we find what 4? Right. And actually, the first thing we did was we found what PS was, right? Using SOHCAHTOA, and that was 4 centimeters, right? And then we used Pythagoras' theorem to get PQ. So in this triangle, Zach, PQS, sorry, you now have the base, 6.9 cm, and the height of 4 centimeters. So you can find the area of the triangle PQS by using the formula base multiplied by height divided by 2. So I did 6.9, the base, times the height, 4, and then I divided by 2, and that's how I got 5.45. Zach.
Miss, I keep getting 13.8
6.9 plus 4 divided by 2.
plus 4. 6.9 plus 4 divided by 2.
Oh, I made a mistake. Oh, Zach. Oh my gosh. Thank you. Why nobody told me about that part?
I keep
It's
getting
base times
8.9.
height. No, you're correct. You're correct. 6.9 times 4 divided by 2. 13.8. Zach, thank you so much. Nobody else told me that I didn't get this correct. Guys,
Was
y'all,
that answer down there correct or
yeah.
no?
No, well, the answer would change because I would now have to add, right? So 6.9 is base multiplied by height divided by 2, not base plus height. So 6, I made a mistake and I added it. Oh my gosh. Zach, you came in clutch there. Wow. 6.9 times 4 is 27.6 divided by 2 is 13.8. Right? So therefore, the total area would be 13.8 plus 17. Oopsie. Thank you. Let me just make sure 8.5 times 4 divided by 2 is 17. It is. Right? So we 13.8 plus 17, which gives me 30.8.
Yeah, miss, that's why I was so confused on how we got the last answer.
Oh, okay. Lord, thank you so much, Zach. Good job. Okay, now I could ask you all, Fire and the others who did it, if you got 30.8 squared cm. Boys,
Yeah, point.
Fire,
Yes,
go. Right. So the diagram below, not drawn to scale, shows the route of a ship cruising from Palm City, P, to Keaton. I feel it's Keaton. Maybe Keaton. Q, and then Rivertown, R. The bearing of Q from P is 133 degrees. So Q from P, Zach, you notice the north line is at P because it's from P, right? So the bearing of Q from P would be the angle between the north line at P and the line PQ. So that's 133 degrees. And the angle PQR is 56 degrees. Calculate the value of angle W. All right. So again, guys, this is using the same principle that if these two north lines are parallel to one another. The north line here at P and the north line at Q, they are parallel to one another, which means that these two angles between the transversal PQ and those two parallel lines are supplementary. It means they add up to 180 degrees. So this angle here, this one over here, is we can find that by saying 180 take away 133 because they would both add up to 180. So this angle here would be 180 take away 133. which is 47 degrees. So this angle here is 47 degrees, right? And how we got it? We said 180 take away 133. Now, the next thing is that angle W, which we are trying to find, 56 degrees and 47 degrees are all on this straight line, this straight northing line, right? So angles on a straight line also add up to 180 degrees. They are also supplementary. So I can find out what angle W is by subtracting the sum of 56 and 47. So 180 take away 56 plus 47. Anybody got to do this
103,
question?
miss.
How much is this, love? 103?
Yeah.
Okay. 180 take away 56 plus 47. I got 77 as the answer.
Yeah.
Well, miss, I added 56 plus 47.
Oh, you just added that alone.
Yeah, my bad.
Okay. So the answer is 77 degrees. So angle W is 77 degrees. You got it now, Zach?
Yeah.
All right. And now determine the bearing of P from Q. Okay, so P from Q means that we will be starting at Q, right? And the bearing of P from Q will be this entire angle between the north. Remember, bearings, guys, are always clockwise.
Clockwise.
Yeah, clockwise. So the bearing of P from Q. So from Q means we starting at Q. The clockwise angle will be the angle between the north line there and the line that connects P to Q. So this whole angle on the outside here. Well, we already know that here is 77 and here is 56. What about the outside here on the straight line? How much degrees would that be?
It'll be sum of, but so if it's out of 360, it'll be the sum of those three minus
Well,
that, the 360.
no, it would actually just be 360 take away 47 because it's all of this over here. If you're thinking about a 360, right? Because 47 plus this entire part, and well, this entire angle that I just circled, that I just outlined in red, which is the bearing of P from Q, that angle plus 47 will make up 360 degrees, right? But also, I know that this little part inside here is 56 and this part is 77. My question was, how much would this angle be over here on the straight line at Q? What is the measure of an angle on a straight line?
180.
180. So this angle is 180. So there are two ways you could find out the bearing of P from Q. You could either just subtract 47 from 360, or you could add 180, 77, and 56. I think I'll go ahead and subtract 47 from 180. I mean 47 from 360. So that's why it's only one mark, right? Because it's just one connection you have to make. So it'll be 360 take away 47. Which is, was it 47? Yeah, 360 take away 47, which
311.
is, I got 313.
Shit. Oh yeah,
Yeah?
my bad. My bad. That's my
Okay.
bad.
So that's one way to do it. If you did it with 180 plus 77 plus 56, you'll still get the same answer, 313. Right? So the bearing of P from Q is 313 degrees. And then the last question, calculate the distance RP. Let's go back here and look at RP. RP is here. You have two sides and the included angle of 56. Which rule would you use? Two sides and the included angle. Which rule
Is
do
it
we use?
cosine?
That's right. Use the cosine rule. So I'm gonna type that real quick. Right, so we're gonna use the cosine rule. And of course you need to write that, okay? Using the cosine rule. Right. Let me type the rest. So it will be PR, which is the side we try, well, RP squared will be equal to the sum of the squares of the other two sides. So 210 squared plus 290 squared. Take away the product, well, 2 times the product of 210 by 290 multiplied by cos of the included angle, which is 56 degrees. Let me make this bigger. Good. So let's work it out. We'll get RP squared. Well, 210 squared plus 290 squared is 128,128 and 200. Take away 2 times 210 times 290, which is 121,800 multiplied by cos of 56 degrees. Guys, you do not subtract 128,200, take away 121,800, okay? You don't do that. You actually have to work out this first before you could subtract it, right? So therefore, RP squared is equal to 128,200 minus 121,800 cos 56, which you're gonna get a big number, 60,090.30436. So therefore, RP will be the square root of that.
Miss, I get a different number.
Okay, what number did you get?
Wait, you put 128,200 minus 121,800?
Yeah.
Okay, then don't worry. I thought you had to do it alone.
I did 12800 take away, 1,200. Oh, hold on, I'm going to type it out. 210 squared plus 290 squared minus 2 by 210 by 290 by cos of 56. Yeah, this. So
Don't
then
worry,
the
Miss, I
square.
get you.
Okay, cool. So then
Sorry.
RP, no, that's okay. Remember just now you had to correct me, so I'm quite okay with that. We're both working things out on the calculator, and you can easily make a mistake, you know? So
Yeah.
the square root of that will be 245.13. So this answer is 245.13 km taken to 2 decimal places. And that's it. That's the solution of all the questions completed, right? So what I want you guys to do